And good afternoon, everybody, or whatever time it is, wherever you're watching from. Thank you so much for joining me here right now. And before we get started, a quick shout out to everybody who made this welcome. Script Runner, Hitachi Solutions, all of the other sponsors, and of course, all of the volunteers who organized this amazing event. Now, as developers, we like working on the latest things. We like to be able to keep our skills up to date and to be able to use the best fitting technologies to solve problems in the best possible way. And more cloud solutions have come to fit this description. And yet, being able to use cloud technologies is sometimes something that takes more effort than we'd like. Some bigger, some older companies can still be really hesitant about making that move to the cloud, whether that's through fear, lack of knowledge, or other internal reasons. Many developers still find themselves working on legacy in-house systems. Your code gets deployed, far too occasionally, with far more effort than you'd like, and you've got no control over how it gets deployed. Should you ever need new hardware, it might be months before you have it available to you. And at a previous employer, this is exactly the position that we were in. As a development team, we desperately wanted to make the move to Azure. In fact, we had a project that was screaming out for it. But our ops team and our budgeting team, absolutely not. Not until you can give us some answers. It's not totally unfair, of course, but you do have to ask what answers are acceptable, because there's reams of research on this, not least of which the State of DevOps report that continually supports this move to the cloud. But we're dealing with people, and sometimes that research isn't enough. For them, it's still an unknown. To be comfortable, they need to see the results and feel it for themselves with their own eyes. And so to get that data that we didn't have, to prove what we could do, we organized a hack week, a chance to show what we could build in a short period of time with the whole team working together, and show the cost at the end of the week. And when I say the whole team, I really mean the whole team. All the development teams, the ops team. We even had our product owners involved to make sure that we weren't just deploying tutorial type applications, but we were making something which could have real world uses for our customers. Hi, I'm Stacy Cashmore. I'm Tech Explorer DevOps at Omniplan in the Netherlands, and I'm a Microsoft MVP for developer technologies. Now, the app that I'm going to show you today, it's a simplified version of one of our experiments, a simple way to get data out of a static Angular site and into Azure storage. Now, before I get started on the interesting stuff, there's a few things I need to say first. Because of time constraints, whilst I am going to be using Azure DevOps to deploy all of my demos here, I'm not going to be talking how that part is done. Also, for those same time considerations, I am using a pre-made Azure environment in order to host my demo, because getting resources up and running in Azure does take time, and it's time I'd rather spend showing you stuff than waiting for Azure to catch up with us. But every resource I use, I am going to be going through the portal and showing you how to create it and talking about some of the options that it has available. And finally, I'm sorry, but this is going to be going at a little bit of a pace. I have a lot to cover in the next 40 minutes or so, but don't worry. There's a link at the end to a blog post that you can follow through and try for yourself, with all the links to the appropriate documentation on MS Docs and on MS Learn. Now, enough of me talking and just looking at slides. Let's have a look at the demo. The first thing that I'd like to show you is just the Angular application, at least the front end of it. We're going to be making a sign up for a book club. So we're going to get people's name, their email address, and what genre of books they're interested in. Now, we're not actually changing this application at all. I'm just using it because I kind of like the user's point of view for this demo rather than just giving you an API that we can call. All of the magic, though, it's going to happen in the backend in the web API. So let's have a look at that. Now, my sign-up API, it's almost as it comes out of the box if you scaffold a new project inside of Visual Studio. Done a little bit of cleanup. I've removed the weather forecast controller and I removed the weather forecast model. And I've replaced them with this book club sign-up request, that email, name, and genre, and a controller, which at the moment is nice and empty for us to add code to. Now, there's only one other change that I've done, which I want to show you for completeness, but it doesn't actually affect the Azure storage that we're using today, and that is in the startup. Because I am hosting a static Angular site, everything is cross-origin, so of course we need to set up cores. So I have it hard-coded here because it's a demo. I'm going to say this repeatedly. Please don't put stuff like this in code hard-coded. But just pointing to the URL where my Angular application runs, and of course localhost, so that I can debug it. Now, today, with the time that we have, we're going to be focusing on getting data from our users and putting it into Azure storage. But we're going to be doing that asynchronously because I want my users to have the best possible experience when using my app. So if they sign up, they click the button, I want an answer back to them straight away saying everything's fine. If we do all of that just inside of this web API, then there's an amount of processing that we're going to need to do when somebody signs up for this book club. We're going to need to make them an account, check their email address, send them a double opt-in maybe, all sorts of things. And these are things that take processing power and time. And if we get lots of users, it means that it's going to slow down. We're going to have to scale up an app service in order to get the performance back. And it's just not the nicest experience. So we want this to be as thin as possible so the users get a snappy response. The other issue is all of these things can go wrong. And if something goes wrong, I don't want my user to have to deal with that. I want my user to know that we're awesome. And if something goes wrong, it's for us to deal with without bothering the user. So for that reason, from this API, what we're going to be doing is storing a message in an Azure storage queue. And then we're going to be reading that out using an Azure function to actually store it properly. So let's get started. The first thing I'm going to do is make a new class, and we're going to call that queue access. So let's just add that one in here now. We'll add a class. And if my machine catches up with us, we can create it. Now, you don't want to be spending the next 40 minutes watching me do lots of typos. So I have an amount of snippets that I'm going to be bringing across and going through with you to build up our application. Now, the first one that you can see here is we're using Azure Storage Queues and also Newtonsoft JSON. And we have a lovely little red squiggle. And that's because we need the Nugget package in order to use these. So let's quickly add those. Manage our Nugget packages. And we're just going to install the latest version. And of course, we're pretty much going to ignore all of the pop-ups that come up because whoever reads these, excuse me. And once that's installed, we're also going to add Newtonsoft, which should hopefully be the top result. And we're just going to install the latest version of that one too. And accept this again. Now, if we go back into our class, everything should be good. And the base class for this is quite simple. We have connection string, hard-coded. Don't do this in production. And we have a queue name, which we're passing into our constructor because we want to use this code for every single queue that we access and not repeat ourselves. So in order to add a message, because that's all we're dealing with today, we need another function. And this is just going to add a message, which is just a plain old object. It doesn't have to be a special message to store a queue. And we have 3 steps to follow. We need to get a queue client. We need to serialize our message and encode it in base64. I'll explain why in a minute. And then we send that message asynchronously to our queue. Now, we've still got some red squiggles here, so let's deal with those. First of all, let's add our Getq client function. Here we have, in 3 steps, a queue client available to us. The first thing we need to do is get our queue service client using that connection string above. Then we use that to get access to a queue using the queue name that we passed into our constructor. And the fun thing here is this queue doesn't have to exist. You can reference a queue which you've not made yet. You can reference it, but if you use it, it's going to go boom and your users aren't going to be happy with you. So we need to do this last step of create if not exists async. And it does exactly what it says on the tin. It checks to see if your queue exists. And if it doesn't, it makes it for you. Then we have a queue that we can use safely. We return it to the previous task. And finally, we need to add this to base 64. And we need this for the Azure function that we're going to be using. In a previous namespace that we could use to access storage queues, this was all done automatically for you. In fact, I know many people who used it and didn't even know it happened until they switched to this Azure Storage Queues API. And then all of a sudden, function stopped working because whilst you can store a plain string queue and you can read out a plain string from a queue, Azure Functions can't. If it's not encoded base 64, it goes boom and puts your message into a poison queue. So we need to add this one. And this is all the code that we need in order to write a message to our queue. The only thing that we need to do now is call it. We're going to do that from the book club signup controller. And I'm just going to do a control dot to import my queue access. And you can see we are getting access to our book club signups, and we're just sending the request in, which is one of those book club signup requests that I was talking about. Now, let's just do a quick build to make sure I've not done anything daft and hope that my computer's not overly slow. There we go. And let's push this up. So we add queue. We're going to push this up to Azure DevOps. I'm going to switch to my browser. Now, the first thing I want to do is just check that my pipeline's been kicked off. Otherwise, in 5 minutes, it's going to be really embarrassing. There we go. And now we can go to the Azure Portal, because now we need to make those resources that we need for that code that I've just showed you. And we need 4 things. We need a resource group to group our resources. We need an app service plan. Think of that like the metal that your application runs on. We need a web app. Think of that like the IIS that your app runs on. And of course, we need our storage account itself. So the first one we're going to create is our resource group. And we're going to call that live demo resource group. And we have to say where we want this resource group to live. Now, I'm in the Netherlands, so I'm going to host it in West Europe. And this region can be a little bit confusing the first time. It doesn't give any defaults to anything else. It stores where your metadata lives. That can have compliancy implications. If you have to keep your metadata for your applications close to your users, then make sure you make this in the right place. So review and create. I'm just going to check I've entered it right, and then we click this create button. And there's our resource group ready to go. Now, in my intro, I told you I'm using a pre-made Azure environment because it takes time, and this makes me look a little bit like a liar. But the resource groups are the exception to the rule. I've never had it take more than a second or so to create. The other resources, they can take somewhere between 30 seconds or so, or the worst I've had was about 5 minutes. So in our empty resource group, let's add the first thing that we need, and that web app, our IIS application that's going to host our web API. Check the subscription and resource groups correct. If you create this from inside a resource group, this should be defaulted for you. We need to give it a name. So let's call it live, and we can't. And we can't call it live because of this azurewebsites.net. This is how you can access your web API from the outside world. And so it needs to be unique inside of Azure. So let's give that a slightly better name then. Live demo web app, and that is usable. That's good. We're going to be deploying to .NET Core 3.1 for no reason other than I've not updated my demo yet. We're going to be running on Windows. There's a good reason for that I'll come to later on in the demo too. And then we need this region. So I want this to be close to my users. So again, West Europe, I'm the Netherlands. Then we need to pick our app service plan. And I quite like this screen in Azure because if you're just playing around, you can create both your web app and the app service plan it runs on inside of one screen. We're going to create a new one here, and we're going to call this Live Demo App Service Plan. And then we need to pick the size of app service that we want to run. So we're going to click on Change Size, and we get this flying on the side. And we get to see all of the different specifications of app service plans that we have available to us. And if the price is ever low, there we go. You can see that it goes everywhere from 62 euros a month up to a whopping 833 euros a month. So make sure you pick the one which is suitable for the load that you expect. And don't just think that because you're in the cloud, you can easily throw metal at a problem without spending too much money. It can get expensive if you don't watch that. We also have this wonderful dev test section here. And this is a much cheaper option when you're playing around, trying things out and seeing how it works. And we're going to be using the cheapest of the cheap, this free one here with 1 gig of memory, 60 minutes of compute time a day. That doesn't mean to say that your app service is only available for 60 minutes a day. But if you're sending requests into your app service, then that compute time is 60 minutes a day. So if you're using 2 minutes of CPU time an hour, then in a day, you're going to be using 48 minutes. For this demonstration, it's absolutely perfect, and it's free. What more do we want? So we'll click Apply here, click on the Review and Create button again. Again, make sure that I've not done anything I didn't mean to, and we'll create that one. And that will now go away, and it will make me the app service plan and then make a web app on top of it. The last thing we need to create inside of our resource group is, of course, that storage account where we're going to put our data. So we're going to create a new storage account. We're going to hope it does something quickly. Thank you. Again, subscription and resource group are pre-filled because we created it from inside of our resource group. We need to give it a name, and this also has to be unique inside of Azure because you can access your storage account from the outside world. So let's call it Live Demo, and we can't do that because for some reason, I honestly don't know why, storage account names cannot contain numbers or symbols. They can only be lowercase letters and numbers. No kebab case, no camel case, no Pascal case. Just big long strings that are impossible to read, I'm afraid. So we want Live Demo Storage ACC. That's available. Then we need to select the region where our data is going to be stored. And again, I'm putting this in West Europe. And this is really important for 2 different reasons. First one, again, compliancy. If I am storing personal data about my users, then I have legal responsibilities of where that data can reside. Again, I'm in the Netherlands. That's inside of the EU. So my data has to stay there as well. So West Europe is perfect for me. The other issue is performance. We want our data to live as close to our metal as possible because you have latency when reading that data. If you're in the same region, it can be milliseconds. You're not going to notice it for most applications. If you host it on the other side of the world, it can take tenths of a second to get that data. And if you're requesting a lot of data, it adds up and your user's experience is really degraded. So you want this to be as close to your metal and as close to your users as possible. Next, we need the performance layer. And as the Dutch say, kort door de bocht, to cheat a little bit here, standard, cheaper, slower, premium, more expensive, faster. It is more complex than that, but for the purpose of today, that's good enough. We need to pick the type of account that we want. And we have 3 options here. We have blob storage, which is tailored for blob storage. We have a storage general purpose V1 account, which is for legacy reasons. It's not recommended using this unless there's a specific thing from that V1 account that you need. Or the storage V2 general purpose V2 account. This is one that we're going to be using today. It gives us access to file storage, blob storage, table storage, and queue storage. Pretty much the 4 things that we need to run this demo. And finally, we need to pick the type of replication that we want for our data. We've got 6 options here. Start with the cheapest one, locally redundant storage. That is, your data is duplicated, I believe, 3 times inside of one data center. And I think this is really cool. On the cheapest layer, you are protected against equipment failure inside of that data center. The data center goes down. You still don't have access to your data. If that's not a risk that you want, you can pay a little bit extra and you get zone redundant storage. This is where your data is copied across different data centers inside of your region. Costs a little bit more, but now you're not only protected against equipment failure, you're also protected against a data center becoming unavailable. Your region, if that becomes unavailable, you still have an issue. Now, this doesn't happen often. I've only seen it 2 or 3 times, I think, over the last decade, but it can happen. And if that isn't acceptable for your application, then you can pay extra and you can go to geo-redundant storage, where your data is duplicated across zones. Remember to think about that compliancy I was talking about. And when you put your data across zones, it means that should anything happen to your primary region, a failover happens and your data can be accessed from that second region. That's all well and good, but it can take time. And if that time isn't acceptable for you, then we can move up the next level to read access geo-redundant storage, which is kind of the same, but now we can read our secondary region all the time. We don't need that failover. You can implement your own heartbeat on your primary region. You can do a manual switch over yourself. You can also, for this one, if you've got data spread out across a larger region, you can duplicate your data to that second region. You only have read-only access to it, but you can still have a local app service and you can get your data directly without having to cross region. Finally, we have 2 new options. I believe they became general availability last year. And that is the geo zone redundant storage and the real tongue twister of read access geo zone redundant storage. If you say it quick enough, you can do it. And these 2 are kind of similar to the geo-redundant and the read access geo-redundant storage, only you get more resiliency. Your data is copied across both zones and across regions. After all of that, for this demonstration, I want the cheapest storage possible, so I'm going to be going for the locally redundant storage. Again, review and create this. Let's make sure that I've not done anything I didn't mean to do. And click create and get that provisioned inside of Azure. Now, check my pipeline and it has deployed. So hopefully now, if I go to this running demo resource group, this is my pre-made environment. I want to show you something before I demonstrate the app. And that is my storage account, the Azure running demo. We have the option here of Storage Explorer Preview. Now, it used to be that you had to install a separate application to be able to look inside of your storage. And these days, it's still in preview. It has some foibles and some quirks, but you can just look into your data inside of the browser without having to install something on your machine. If you want to do something complex with your data, that application is still a far better option. But for just having a quick check at your data, this is fantastic. And what I want to show you is that I have no tables and I have no queues. Like I say, that code, that create if not exists async, should create these for us as we go. So back to our book club. And we have Ms. Amy Pond. And Amy Pond is traveling on the TARDIS. And anybody who knows Amy knows that she's interested in 40s crime noir. So we're going to submit this. And hopefully, if I refresh my queue now, I have a queue created for me. And here's Amy ready to be processed by our Azure function. So let's get on with the Azure function now. I have a clean Visual Studio here. We're going to create a new project. And the template that we want to use, come on computer, you can do it, is Azure Functions. And for this one, we have a little bit of setup that we need to bring across. I want to call my function app book club signup processor. And so that it gets picked up by my Azure DevOps, I need to store it in a particular backend. which apparently was already filled in. So we're going to create this and wait for that to come up. And when you create a new Azure Function application, you get to pick the kind of trigger that you want. What do you want scaffolding? You can have nothing, completely empty. Or you can have blob triggers, Cosmos DB triggers, event grid triggers, HTTP triggers. I don't actually need to run a full-on app service web API in order to get data from my users. I can do it with a HTTP trigger. There's a reason why I don't just yet. Again, come to that later in the demo. The one that we are interested in today is this queue trigger. And to use that, I want to connect up to my queue. And I want that Azure running demo. The connection string name, this is what you're going to use in production so that you can set up all of the correct connection strings to talk to different storage accounts. I'm going to cheat for this demo. I'm going to leave it empty. And that means we're just going to be talking to the same storage account where the Azure function itself is hosted. And we need to access our queue. And of course, that queue needs to be the same as the one that we've just made, which would be our book club signups. So let's create this and scaffold it up. And when we do that, come on, you can do it. Wow, I apologize for this. My computer's gone on a go slow. Normally this happens in like seconds. Okay. First thing I want to do, just because I really hate having function 1 inside of my application, is I just want to rename this book club signup functions. And yep, I want to, thank you, rename my class 2. I also want to change this function name attribute, and this is how it appears inside of the Azure portal. Now, there's a fun thing here to know, and that's this cannot have spaces in it. I did that once by mistake. I didn't spot it. It built. It deployed. It never appeared inside the portal, and it never fired off. And I pulled my hair out for an hour until I found that space because I couldn't see any errors of why it wasn't working. Don't be me. Don't put a space in this. Then we need to remove this connection string or this connection. If you put a connection string in the wizard to scaffold up your Azure function, this is where that one appears. And lastly, well, that's it. We now have an Azure function, which will trigger every time a message comes into my queue, give me a string, which has been decoded from base64, so just a JSON string that we can deserialize and use. But why would we want to deserialize our own string when Azure functions can do it for us? So I'm going to make a new class here, and we're going to call that book club sign up request. And I'm going to cheat a little bit here, and I'm just going to go back to my sign up API, and I'm going to copy this class across. Paste that in here. And now in my book club function, rather than expecting a string, I can say expect a book club sign up request. And I want to call that request because it makes slightly more sense to that naming that I've just used. And now I get an object coming into my function, which I can then use. So now we're going to store this object inside of an Azure storage table. So for that, the first thing I'm going to do is make a folder to try and keep my code slightly neat. Come on, you can do it, little computer. Going to call that table access, and then we're going to add a class in there called storage table access. Add class storage table access. And the same as I did for my queue, I've just got some code snippets that I want to bring across here. And you can see that we are using Azure Cosmos table with a nice red squiggly line underneath it because, yeah, we need another NuGet package for this. So let's manage the NuGet package. Let's browse. And you may notice that I've said Azure Cosmos table here, even though we're using storage accounts. We're not doing anything with Cosmos DB, but they share an API, which It's really useful because it means if you need to upgrade to Cosmos DB because you reach the limitations of storage tables, you can do it automatically with this. You can just point it to a Cosmos DB with table storage and it will work for you. And now the red squiggle's gone, you can see that this looks relatively similar to our Q class. We have a connection string, don't do this in production. And we have a table name that we're passing in through the constructor, because again, we want to use this for all tables. And to insert data, we're going to need a function for that. And that gets in an entity, which is a table entity, also from that Microsoft Azure Cosmos table namespace. It's a special type of object that you need to work with tables. We're going to get access to our table. We're going to create an insert operation based on that entity, and we're going to execute that against our table. So how do we get our table and get rid of that last squiggly line? Well, pretty similar to the way that we get a queue. First of all, we connect to our cloud storage account using that connection string. Then we get access to a table client. From that table client, we reference our table. Remember, they don't have to exist, but if you try and use it, it will go boom if it doesn't exist. So we need this create if not exists async underneath. We pass this back, we can now use it. And for simply inserting data, this is all that we need to do. What we do still need is an actual entity to sign. So let's create a second class in here. And we want a class. And we're going to call this sign up entity. And this sign up entity, if I can get my code, this sign up entity is inheriting from that table entity that we're passing into that insert function. And for a table entity, there's two things that you really need to use. We need a partition key, and that is how your data is partitioned inside your storage account. And we need our row key, which has to be unique inside of that partition. That means you put the two of these together and you get your unique identifier for your record. Now, I really don't like having partition key and row key spread throughout my code because it doesn't match the rest of my code. So I have these ignore property attributes that I use so that I can rename them. And I call the first one genre subscription, because I think my genre is a reasonable thing to partition my data over. And because I completely ran out of imagination, I just call the second one unique name. Now that we have our entity, we need the fields that we're going to store, because right now we're still not storing any data, of course. So let's just add those in, our name, our email, and our genre. And this is all the code that we need for inserting into our table storage. All we need to do now is call it. So let's get rid of this logging line and replace it with this. Because we're calling an await method, obviously we need to make this async. Do control dot to bring in the usings. And here you can see that we're getting access to our book club signups table. And we are taking our request, which isn't a table entity, so we have to adapt it. And we're inserting that into our table. Now, you're going to write proper adapters if you do this for real. But for the purpose of this demo, I'm just going to add it down here. And this one needs to be static. We take in our request and we just return a sign-up entity with the name, email, and genre copied over. Of course, we also need to set those two special fields, the partition key and row key. I'm setting the genre to be the genre subscription, the partition key. Now you're going to have some really spectacular, intelligent data crash algorithm running in your code to make sure that you don't get duplicate data. I'm not. I'm simply taking the ticks from datetime now, appending that to the name that comes in on my request, and using that to ensure that pretty much every request I get is going to be unique. Now, hopefully, if I build this now, hopefully it builds. Yay, there we go. I can now push this up to Azure DevOps, and we can get this one deployed as well. So add function, commit and push, and let's go back to our web browser. Check the pipelines running. Please check the pipelines running. There we go. So we need to go back to our live demo resource group because now we've added an Azure function. So you can see that we have our app service plan web app. We have application insights because we didn't turn it off when we created our web app. And we have our storage available to us. So now let's click on this add button again and make our function app. For the last time today, we're going to check that the subscription and resource group match. They should always match, but I always just check it anyway. You never know. And then we need to give it a name. And you might have guessed, especially looking at this Azure websites.net here, this has to be unique inside of Azure, not only for functions, but also across web apps. Live demo function app. But that is useful. We're going to deploy .NET. Here we're deploying 3.1, not because I've not updated my application yet, but because .NET 5 isn't yet supported. I don't know when it's going to come online. I do know it's being worked on. And again, we want to host this in West Europe, so we're going to set that one up. Now, for a base experience of just playing around with these things to see how they work, out of all of the resources I've showed you today, this is the only one where really checking that second tab is important, because every function app has a storage account associated with it. And that's because when your function isn't running, it needs to live somewhere. It doesn't actually exist. Azure gets a request to your function app. It spins up your function for you, getting the data out of a storage account. And then after it's been lying idle for an amount of time, it tears it down again, waiting for the next request. So for that, we need a storage account. And I'm going to pick the one that I created, the live demo storage account. Now, you can only select an account which is in the same region as your function app. And again, that's because of that data latency. If you're copying data across to spin up a new function app when you get a request in, you don't want that data coming from the other side of the world. You want that data available instantly to you. We're going to be running on Windows, and we're going to be running a consumption serverless app service plan for our function app. And actually, that consumption app service plan is the reason why I am running Windows here. If we set this to Linux, then there's a limitation inside of Azure at the moment. You can only have one Linux consumption-based app service plan inside of a resource group. In fact, if you have a Linux consumption-based app service plan inside your resource group, it can be the only app service plan, which meant we wouldn't have been able to add our web API. Now, obviously, we could do both of these on Linux, and we could host them in different resource groups, but for the demo, it's easier just to put them together. Hence, we're running on Windows. And then we need to pick the type of plan that we want. And we have three options here. We have the consumption serverless. That is the free tier. You get 1 million function calls per month, I believe. If you need more performance in your function zone, then we can go up to the premium layer. That's quicker. I believe you get a code scale out instance always waiting for you. So that initial time on that first request is faster. But obviously you paid more money for it. You can even run your functions on just a plain old app service plan. But of course, if you do that, you kind of lose the benefits of the serverless side. I'm going to be going for the consumption here. The free tier is perfectly fine for what I'm using. So we'll review and create this, make sure again that I've done it right. And that all looks good, I think. So let's create it. Now here comes the scary part about my plan. I have an issue with one of my pipelines. The function doesn't always deploy as it should do. Let's see whether or not it's worked for us. If we go to my running demo and everything has gone well, we should be able to go to the storage account, to the storage explorer, Thank you. And hopefully we will see that our queue isn't empty because the deploy hasn't worked again. I'm going to kick this one off a second time. I don't know what this is. It's something to do with the YAML pipeline and deploying an Azure function. I'm just going to redeploy it. I'm not going to rebuild it. It's literally something in this deploy stage. And hopefully that's going to come through in a second. Right, rather than waiting for the minute for this to go, I'm going to finish off my presentation, and then I'm going to come back and hopefully show you that you don't just have to trust me that this works, but it really does. So getting back to the presentation then. One of the reasons why we went through this whole process with my previous employer was to figure out what it was going to cost. Our budgeting team had visions in the head of us spending hundreds of thousands of euros moving from our data center and into Azure. Well, for this talk, as a very small example, with lots of practice, writing it, dry runs, lots of mistakes, giving it at various conferences and meetups, I have spent 20 euro cents over the last year. In fact, I think that might be over the top. It might be closer to 15. And by making sure that I picked the smallest things that I needed, so using the Azure cost calculator to have a look at what I could do, I managed to build this without spending much money. Of course, this is a tiny little demo. You'd hope it didn't cost much money. So for a bigger group, well, the Hack Week that we had, a whole department trying different things, 6 teams using lots of different options, not just functions and storage accounts and app services, but also machine learning, Azure Signal R services, the whole gamut of options available to us. And it wasn't just the first week. It wasn't just that Hack Week. The week previously, our ops team was busy playing with VPNs inside of Azure, trying different things, making sure it was as secure as they wanted. And we also devised a workshop for our developers who hadn't worked with Azure yet so that they could hit the Hack Week running. Total cost for both weeks, 25 euros. Now, yes, when you're using cloud services, you do have to be careful. If you spin up the wrong resource, you can get a very big bill very quickly. So you do have to be careful. But if you keep an eye on your costs, if you use that Azure storage calculator to make sure that you're doing the right things, you can create a lot of value without it costing a fortune. So I invite you to play, experiment, try things out. If you're lucky enough to have an Azure Visual Studio subscription on a yearly basis, you have Azure credit available to you, somewhere between 45 and 130 euros a month, depending on your subscription. Use it, because that credit limit is a credit limit. Even if you do something wrong, I've done this, you don't actually go over that limit. It just reaches that point and your resources stop working until the next billing period. If you don't have that subscription, you can, of course, take your own private subscription. If you do this, you get 12 months of selected services for free, 170 euros of credit in the first month with that credit limit. So if you do something wrong, you don't instantly get hammered on your credit card. This is obviously a more dangerous way of doing this. It's your credit card. So if you do this, please use that as your cost calculator and make sure you know what you're doing before you press that button to spin up new resources. Now, hopefully you've seen here how quick it can be to quickly start to use some of the resources inside of Azure to make a disconnected way of getting data into our storage. So go have a play and see what you can build. I'm going to come back to this screen in a minute because I promised to go back to my demo. Come on, refresh. Yay, my data's gone. And if I refresh my tables, we now have that book club sign-up table created by my function app, and Amy is there inside of our system. On that note, I say I do appreciate that this was a very quick run through. The QR code will get you to my blog post to tell you how to do this yourself. And as I say, there's also the links to the Microsoft Learn and the MS Docs there. On that note, thank you very much for your time. And if there's questions, I'm hoping I'm going to see them in my chat on my other screen. Do we have any questions? Okay, I'm not seeing any questions come up, and I believe I'm pretty much out of time. So thank you very much for your time. I have enjoyed today. I hope you enjoy the rest of the day. Doei doei.